Paul's assignment for Lesson 28 was to set up a Wi-Fi client-server relationship between the PC and the Raspberry Pi Pico that actually does something. Also, the Pico should be battery powered, not connected to the PC by USB. I thought I would start by expanding one aspect of Paul's in-class server code. After issuing the connect statement in line 10, the in-class code goes into a while loop which will run until the Pico is connected to the specified local network. But especially since the Pico is going to be battery powered, we might want to use the client server somewhere where we don't have the credentials for Wi-Fi, or maybe there's no Wi-Fi at all. In such a case, this while loop will never finish. We could have the Pico generate its own Wi-Fi network though. This is known as access point mode. Then, in terms of actually doing something, the client in this assignment will poll the server for temperature and humidity data on a fixed interval. When the data is returned, the client will save the data to a text file in comma-separated variable format, which will facilitate loading it into Excel for further study. And because I've received some questions about the secrets file, I thought I'd start with a brief explanation of that. There's no secret to the secrets file. It's a Python file, which really means the file name ends in .py. So it's secrets.py. You save it to your Pico, and it contains 2 lines of code. An example is shown on the left. SSID equals something in quotes, and password equals something else in quotes. You put your credentials in those quotes. Once you import the secrets file into your application using the import secrets statement, you can refer to your SSID and password in your app by using secrets.ssid and secrets.password. That's all there is to it. No one will be able to learn your real credentials by looking in your app. So now let's have a look at the server-side code. We start with the usual imports. A number of functions follow here which I created to simplify the use of the OLED display. There's a function to clear the blue area, display blue text, display message, and so on. For the most part, there's simply OLED commands in a function. They're not directly related to the current assignment, so I won't waste your time on explanations. Program execution starts with some variable declarations. Notice that we declare 2 new credentials here, access point SSID and access point password. Those will become the credentials of our network whenever we wind up in access point mode. Next, we set up the DHT sensor, the I2C channel, the OLED display, and the onboard LED. Finally, we display setting up Wi-Fi on the top line of the OLED and begin setting up the Wi-Fi. Pico W keeps track of the reason for its most recent reset with the reset cause function. This function accounts for a number of reset causes. 2 of those causes are useful to us in this assignment. If the Pico is powered off, then on, then reset cause will return a 1. If the Pico was reset by code, then reset cause will return a 3. When the program reaches line 136 after being powered off, reset cause will return a 1, and network mode will be set to station mode. On the other hand, if the Pico was not powered off, but was reset from the software, then the reset cause will return a 3, and network mode will be set to access point mode. If the reset cause is anything else, we fail gracefully and stop. After a power on, when we're in station mode, we define the WLAN object using sta_if, and we activate it. Next, we try to connect to the local network using the credentials we read earlier from our secrets.py file. In a loop that counts down from 10 to 0, we check wlan.status to determine if our connection is a success or a failure. If our connection is successful, we display the appropriate status messages and move on. But if our connection is not successful, we display status messages about that and actually reset the Pico. Because this server program is running as main.py, resetting the Pico triggers a reboot. When our code comes back here, network mode now will be access point. If you're not clear about that, look back at line 139. So now that our network mode is access point, we'll attempt to set up our own access point rather than joining an existing network. After a reset, when we're in access point mode, we define the WLAN object using AP_IF and activate it. Notice this does not require our secrets credentials. We're creating a completely new network with an SSID of access point SSID and a password of access point password. In a loop that counts down from 10 to 0, we check WLAN active to determine if the access point is created or not. If our access point is not created, we display a status message about that and fail gracefully. Otherwise, we move on. Here's what the user sees when the Pico logs on to a local network in station mode. And here's what the user sees when the Pico cannot log on to a local network and resorts to access point mode. Notice the Pico network has a unique IP address, 192.168.4, so your client has to log on to that. At this point, the Pico is either a station on an existing network or it is providing an access point to its own network. In either case, we need to create a socket to be the server endpoint for messages. We also need to bind that socket to the network. Now that we're on a network, we can serve some data. As expected, the server logic is inside a while true loop. We start by toggling the onboard LED as a heartbeat, and we provide a small delay for the DHT sensor and then grab temperature and humidity readings. Next, we wait for and receive and decode messages from the client. We update the OLED and verify that the client request is valid. In our case, TH is the only valid request. Receiving TH causes the server to prepare, encode, and send both temperature and humidity data to the client who asked for it. Now let's have a look at the client side of the program. We start the client program with our imports as usual. This time we add date time to the import list because we're using time calculations later in the program. Program execution starts with some variable declarations. We create a socket to be the client endpoint for messages. We set two time-related variables to the current time. We calculate how long we've been waiting for data and request the data when the waiting time reaches the sample interval. The request is simply TH, temperature, humidity. We encode the request and send it. We wait for the response from the server and decode it when it arrives. We're print a summary of the data in the shell and save the data to the CSV file for later analysis. The format of the data that we write to the file is completely arbitrary. It includes the IP address of the server, so we know where the data came from, and then a timestamp, so we know when the data arrived, and then the actual data, followed by /n, so that each line of the data is on a separate line in the file. Once that's done, we update the current time variable and continue waiting. And here's how it all works together. Here's what someone looking at the server would see, and here's what someone looking at the client would see. This is what the raw data file looks like. And here's what the data looks like once it's imported into Excel and prettied up a little bit with a graph. And the cherry on top, the server is outside running on a battery. Well, this has been a long one. I hope you enjoyed it. Any and all comment is welcome. Please hit the subscribe button and the notification bell, and we'll talk to you in the next homework. Bye for now.